Hello all. This program is related to convert decimal number into hexadecimal, or you can tell binary also. So we have to write a assembly language program and we have to execute so that input will be in form of decimal number and output it will be displayed hexadecimal equivalent of that. So anyhow we know the all the numbers that is handled by 8051 microcontroller is 8-bit and it is going to be handled in form of hexadecimal, but we are writing the logic such that the input whatever we will give will output a display, it is going to display the number in form of hexadecimal equivalent. So the output we are going to display in a memory location that is nothing but 40H. So 40H location I should get the hexadecimal equivalent output of the input it will be given. So input will be given to a internal accumulator register and it is going to display the output in internal memory 40H. It is assigned to display the output in form of hexadecimal equivalent of that. Just for our quick reference, what I'll do, I just open one web page. So that is showing how we can perform that operation called conversion. So let us see this web page. So we have taken a number that we have taken an example directly from the web page that is showing convert the decimal number 49 into the hexadecimal. So what we have to do? So what is the steps? Just we are going to identify what is the steps manually we are going to perform. Same thing we are going to represent in form of our assembly language programs. So let us consider we have taken 49 and we have to display the equivalent output. So we know the 49 decimal number output should be 31. So 49 decimal hexadecimal equivalent is 31H. So how it is happening? So 49 we are going to divide by 16. 49 input number, 49 decimal number, we are going to divide it by 16. Or 49 we are going to divide in form of hexadecimal calculation. If I tell 49 we are going to divide by 10H. 10H, you know, it is nothing but the 16. So if I divide 49 by 16, so after division quotient will be 3 and remainder will be 1. So that is the first hexadecimal value for the LSB. So whatever the we are going in downward direction, whatever the remainder will be getting as a result of this successive division. So this remainders will be arranged in form of LSB to MSB that will form a hexadecimal number. So that is the logic. So what we are going to do, every time the input number we are going to divide by 16D or we are going to divide by 10H, and after this division whatever the remainder will get, that remainder we are going to make or shift in the position of LSB to MSB direction, and finally whatever the number will get, it is nothing but the hexadecimal equivalent of the decimal number. So for this case 49, first division 49 divided by 16, quotient is 3, remainder is 1. That remainder will be placed in the position of the least significant bit position, byte position, or least significant digit position, that is nothing but 1. First position is 1. So next, what is the quotient we got according to the successive division? One more step I have to do. Our next step is successive division tells quotient will be divided by again by the same divisor. So 3, now 3 divided by 16 decimal or 3 divided by 10 hexadecimal number 10H, that will give me the quotient is equal to 0 and remainder is equal to 3. So we'll consider that 3 is the most significant digit in my hexadecimal equivalent. So this is nothing but 49 is equal to 31. So this process will end, this process will keep on happening unless and until this quotient is becoming equal to 0, or we'll terminate this process once the quotient becomes equal to 0. One more problem we'll see, anyhow we are not going to do. So the decimal number we have taken 1228. So what is the hexadecimal equivalent of that? So 1228 divided by 16, first division, quotient is 76, remainder is 12. 12 is nothing but C. Then 76 divided by 16, quotient is 12 again. Again it is C. Then the quotient is 4 divided by 16, remainder is 4, and so it is 4, and quotient is equal to 0. This terminate the process. So now, so it will be in the reverse order, it is saving. So 1228 decimal number equivalent hexadecimal will be 4cc. So like that example it is. Now in our case, as it is as any register can contain a 8-bit number, so maximum input we can give in our case, it cannot be like 4-digit number, or it cannot be 3-digit number, only 2-digit number input we can give. So let me take the program and let me execute the program in our editor window. So I am copying the program and I will open the kill software, and I am going to perform again this operation called execution of this program. So let me open it from beginning. So counter program I don't want, so already it is, so I can remove this program. So what I am going to do, I am opening one file, new file, and the program whatever it is there, I am going to copy as it I have written it before. So, and if we want, this much is sufficient. Again, if you want, you can add that initial 3 lines, that org 0, then bypassing the program, all these things. So let me copy that also, Control V. And then what I have to do, I have to save it, file, save. I have to save with some name like decimal, decimal to decimal, just a decimal I'll write. Dot ASM is the extension. Save it. So once I have saved it, I have to add it to the source group, add existing files to group source group 1. I'll add it. I'll find out from there what is the name I have given, decimal. It is available. Add, close. Then what is the next step? Next step is I have to build target. Build target will show me this, there is 0 error. I can have one more round, that is nothing but rebuild option. So once rebuild option is done, so next step is debugging. So before going in debugging, just I will tell you the program logic. So first 3 lines again I am not telling. Next line is move a comma has 95. So I am taking an input, it is 95. So 95 is my input. I should get the equivalent hexadecimal of that. I should get equivalent hexadecimal of that. So what will be the equivalent hexadecimal of 95? So if I open the app, that is nothing but the calculator. Calculator will tell me if I open the calculator in scientific mode, I'll get all these calculations see decimal to hexadecimal. Decimal, let me check decimal 95. So equivalent hexadecimal should be 5f. Decimal 95 equivalent hexadecimal should be 5f. Now let me go back to there. So what I have done, so 95 I have given to the accumulator, and as I told, it is like successive division process. So it should be divided by 16 decimal, or it should be divided by 10 hexadecimal. So I have loaded b is equal to 10. Then I have performed division operation. So what will happen? I will get the quotient and I will get the remainder. So quotient is for next level of division. Remainder is just to store the LSB value of the converted output. So then what I'll do, that LSB value of the converted output, that is nothing but a remainder, is available at B register. So we are going to copy it to R1 register. Let it be for R1 registers for time being. Now what I am going to do, I am going to store B is equal to 10. Or B is equal to A, 10 in decimal, and B is equal to A. So let it be B is equal to A. B is equal to A. Then what will happen? So in this case, 95 divided by 16, 95 divided by 16 is 95 divided by 16 is like 15, And now what will happen, so in this case I have to get the value in form of hexadecimal. So what I have done, after storing the remainder in R1 register, I have to perform, I have to conversion will take place. So what I have done, I have taken decimal. So what will happen now, this B I have stored, B I have copied A, or in decimal it is 10. So now what is the value is there in accumulators, that is the quotient value, that should be multiplied with B, that should be multiplied with B. This is nothing but the decimal 10. So I'll form a number in hexadecimal. So I'll form a number in hexadecimal. So in that case, whatever the number in hexadecimal that is there in, that is the result after multiplication, it is there in A register. So whatever the value I got as a first quotient, whatever the value I got as a first quotient, that will be always there till this moment in R1 register. It will get added. It will get added with accumulator. And what will happen now, finally the result I am going to display in 48. So let me execute this program step by step so that it will be more clear for us. So I'll debug it, and anyhow we are going to display it in a window called memory window. So I'll open a memory window, again view, go to memory window, memory 1. So it is internal memory. So D colon, what is the number, 48 is the location, enter it. Now let me run this program step by step. So what will happen first, so I have to click step by step, means F11 directly, or I have to click on this icon. So initially what will happen, let me open the register window also. So initially what will happen, if I click, so A value, so first you can see A value is loaded as 95, that is my input. Then next line, B value is loaded as 10 hexadecimal, that is by which it is going to be divided. Then I will perform division. So after division, this A value is equal to 9 and B value is equal to 5. So 95 divided by 10, I am discussing everything in hexadecimal point of view, because microcontroller 8051 only understand the hexadecimal numbering system. So 95 divided by 10, it will become 9 as a quotient and 5 as a remainder. So now what will happen, next step, for future purpose, because B I am using for again for next level of calculation, hence what I will do, that remainder I will store it back to R1 register. So if I execute again, so what is the remainder value, that is there in B register, that will be copied in R1 register, that is also 5. Next level is what I am going to do is the multiplication. So now I am going to load the new value for multiplication to B register. So you can see now change, B is equal to 0A. So after B is equal to 0A, so 0A will be multiplied with 0A, that is B content will be multiplied with A content. What is A content? A content is 9. So it is this level only the conversion takes place. Now B is equal to 0A, A is equal to 9. If I multiply, I will get the result in accumulator is equal to 5A. I will get result in accumulator is equal to 5A. So this is the hexadecimal conversion takes place actually in this level. So 9 multiplied by 0A, it will become 5A. It is there in the accumulator. And what is there in B? What is there in R1? R1 content is after first division, that is nothing but 5. So that is there in 5. So next, if I execute next level, so what will happen? 5 was the content of R1 and A content was 5A. So it is getting added together. So we'll get 5F. So 5F is in the accumulator. So again, if I execute further, so the output will be displayed in form of hexadecimal. Output will be displayed in form of hexadecimal output to the location, internal RAM location, as we have specified in our program. That is 40H address. So 40H address will get 5F. So as we have seen in our calculator mode also, that hexadecimal equivalent of 95 is 5F. Hexadecimal equivalent of 95 is 5F. So it is making, it is making this calculations, this program is showing us the correct calculation or correct conversion of the input whatever I have taken 95 is equal to 5f. So you can take any numbers, but as a register we are going to consider to store the number or give the input. So hence you can give only the 2-digit numbers like this. So you cannot take more than that. So you can take only 2-digit number, and it will show the hexadecimal equivalent of the output to accumulator register as well as the internal memory location 5. Thank you.